Okay, we are going to continue talking about our rational expressions. That's what this whole unit is about for us. So what I'm going to do is I'm going to start off section 6.2. I want to get us all to a place where hopefully we can feel comfortable so that we can move on from there. So first thing we're going to do when we look at our adding and subtracting rational expressions is we're gonna step back to the best case scenario. So you'll notice my first two examples up at the top. What do you notice in example 1 and example 2? What do you notice about the denominators of the fractions that I'm going to attempt to add and subtract? They're the same. That is, for us, the key. And I think that's where we go off the rails with fractions, because multiplication is just tops and bottoms, very straightforward. But when we get to adding and subtracting, we have to remember that the denominators have to be the same. Our fractions have to represent the same ratios. But when we do have the common denominator, everything is good. Does anyone remember what we do to add or subtract when I have a common denominator? Perfect. Thank you. You just add or you subtract the numerators. Very straightforward. Okay, so here we go. 3 plus 5 here is going to be 8, and then you leave the denominator alone. Okay, once you have a common denominator, you've done all the hard work, so you just write 8 over 11. So that is that. So example 2. The reason I put a second example for me of this is the process is the same when you have variables in the denominator, as our rational expressions often will. So again, you've already identified that the denominator here is the same for both of these. So now it's just a matter of either adding or subtracting, whatever's appropriate, those numerators. So in this problem, it's a subtraction problem. And so I have 7 minus 11. Our calculator will tell us 7 minus 11 is what? -4. And then again, the denominator stays exactly the same. So the denominator is going to be 2r squared. Nothing left to do there. So far, any questions about adding or subtracting fractions? We good up to here? Okay, so what we're going to do is we're just going to spend some time now practicing this. And also, we're going to combine a little bit some of the problems we do. We're going to remember our skill from last time of reducing fractions, because we always reduce them. So we're just going to go one at a time. I'd like you to look at exercise 1, and I'd like you to go ahead and add those two fractions. And if necessary, make sure you reduce your answer. Okay, so the first step, the new part for today, is I'm going to add these fractions. Again, I've got the common denominator. We're not focusing on that just yet. When we turn the page, we'll talk about common denominators and getting those. So here we go. The denominator is common. So 6 plus 14 is 20 over 5x squared. So if you did that, you've done the new bit just fine. And then we have to ask ourselves, is there a factor in common between the numerator and denominator here? 5, sure. So I see that 5 goes into 20 4 times, 5 goes into 5 1 time, and I'm just going to rewrite that fraction now. So the numerator has reduced to 4. The denominator has reduced to 1x squared, which I'm just going to write as x squared. You got a question about any of these? I understand. Adding and subtracting fractions, this is where sometimes we get befuddled. I don't want you to be that way. I want you to leave here feeling pretty decent about this. So exercise 2, if you got a question, ask it. If not, turn your attention to exercise 2. So in my numerator, the 3x and the 12, are those like terms? No, so I can't combine those into 15x or anything like that. They're not like terms. And the reason I mention that, and if you did do that, okay, forgive yourself. The next problem, you're going to get the chance to that redemption there. But 3x plus 12 is just going to stay 3x plus 12. And then the denominator is x plus 4. Okay, so all I've done is I've combined my two fractions into one fraction. I can't combine those two terms because they're not like terms, so I just leave them 3x plus 12. Again, if you got to there, great. If you didn't get to there, that's okay. Exercise 3, 4, and 5, you're going to get the chance to do the same thing again. I do have one more step. Again, that's kind of my purpose in these problems, is reminding us of where we've been last time. And so notice I can factor a 3 out of the top of this. 3x and 12 have a common factor, so I'll factor the 3 out of that. 3x, when I factor out the 3, leaves x. 12, when I factor out the 3, leaves plus 4. Oh, very cool. Look at that. I have a common factor in the numerator and denominator. It's that x plus 4. So I'm going to cross it out just like we did yesterday, or not yesterday, Monday. And what I'm left with is a 3. That 3 is in the numerator. It's up top. So my answer is just 3. All right, well, maybe you didn't know to go that far with the problem. Maybe you didn't know what to do at all because those weren't like terms. I totally get it. That's why we're going to do exercise 3. It's a very similar example as the previous one. So go ahead and run through that and see if you can simplify what you get there. All right, so this problem, again, we've got the common denominator. That's not the thing we're focusing on right now. We're focusing on combining these fractions. So when I combine these fractions, what's the numerator going to be? What do I have up top? Yep, again, they're not like terms. So it's just going to be x minus 3. Great job. Okay, so perfect. And then the denominator stays x squared minus 9. So again, if you got there, that's a great step. You're doing really good. Let's just not forget what we did last time. Let's do some simplifying here. So the top, the x minus 3 stays the way it is. We notice the denominator, that's a difference of squares, x squared minus 9. What are the two factors of x squared minus 9? Yep, I believe what you said. I think I heard it. My hearing's not so great. X plus 3, x minus 3. We need those 3's. Different signs. I can now cancel out the x minus 3's. And here's what I'm left with. I'm left with an x plus 3. How do I have to write my answer on this one? Perfect. Excellent remembering. We talked about that last time. The x plus 3 is in the denominator, so we've got to write that as 1 over x plus 3. Excellent. You got a question, raise your hand, ask it. Let's talk about it. Let's get it out in the open. I can come to you if you'd like. Exercise 4. We got 2 more problems that have the common denominator and we have to reduce. So exercise 4 is the next one. Right, so in this one, there are some like terms in the numerator. Okay, so I'm going to combine those. I notice I've got the 5x and I'm adding to that negative 3x. What do I get when I combine those like terms? 2x, great job. Thank you very much. And then I have 6 plus 4. I'm going to assume we all said 6 plus 4 is 10. The denominator, again, once you have the common denominator, that is kind of the point I'm trying to make here with these problems. Once you do have a common denominator, you don't touch it. Okay, denominator doesn't do anything when you add the fractions together. So this is what I get. This is my new combined fraction, 2x plus 10 over x squared plus x minus 20. If you got that, that's an unbelievable job. Great work. Now what I'm going to do is I'm going to practice what we did on Monday. I'm going to go ahead and reduce this. So in the top, what can I factor out of the top here? A 2. Yep, great job. Excellent. So 2x, I factor out the 2, that leaves x. 10, I factor out the 2, that leaves me 5. Wonderful. The denominator, I have a trinomial. There's a 1 in front of the squared term, so I'm just going to unfoil this. So I'm just going to, here's my parentheses. X squared, the only choices for x squared are x and x. Again, bear with me. I'm just trying to help these things get burned into your long-term memory, so I'm asking you these same old questions. What does the negative 20 tell me about the signs of my two terms? Yep, a negative and a positive, so I'm going to put them in the order that you told me. Positive or negative, it doesn't matter the order that you write them down. And then I need the two factors of 20 that are going to be 1 apart. What are those two factors going to be? Yep, negative 4, thank you, and 5. And why did you, explain to everybody, why did you make the 5 the positive one? Perfect. Excellent job. Okay, great. It sounds like you're getting this a little more and more. We're just going to keep repeating this. It's great. So the x plus 5s cancel. It was all worth it. And so then I have 2 over x minus 4. Here's a review question. Don't fall into my trap. Can I cancel the 2 with the 4? Why not? The 4 is a term. Okay, the 4 goes with the x. It's either all or nothing. You either cancel the whole x minus 4 or you don't cancel any of it. Okay, great job. All right, one more of these. Exercise 5 should be very similar. I'm going to give you a little hint though. I included this one because it's a subtraction, and I don't want you to end up missing this. If you had me for introductory algebra long ago, whenever you had that, and we were subtracting polynomials, here's what I would have told you to do. Whenever you're subtracting, you have to remember somehow that you're subtracting everything that comes after. Not just the 3x, that's not what students tend to miss, but you also have to remember to subtract the negative 7. That's sometimes what the students miss. So here's what I would recommend. I would say take this negative right here and let's distribute it. Okay. So what I'm going to do is I'm going to take this negative and I'm make that a negative 3x and I'm going to make it a plus 7 and I'm going to add those things together. I just changed the signs. That's the way that I help myself remember that I have to subtract everything that comes after that minus sign. From there, I'm going to let you take the reins from there. There'll be more subtraction problems a little later in the class. So let me add these things up, see how you did factoring, and then we're going to talk about the other things. So this is like half the process here, what to do when you have the common denominator. You just add those numerators. So 8x and then negative 3x or 8x minus the 3x gives me 5x. And then 13 minus the negative 7, which makes 13 plus 7, that is 20. The denominator does not change at all, so the x squared plus 7x plus 12 stays just the way it is. That is the added together, the subtracted expression. Now I have to simplify that. So in the top, we can factor out a 5. 5x factor out the 5 leaves me x. 20 factor out the 5 leaves me 4. The denominator is a trinomial with a 1 in front of the x squared, so I can unfoil. So x squared is x and x. What do the signs of this have to be? Both positive, because the 12, remember, tells me they have to be the same. The 7 says, okay, that means they're both positive. And the two factors of 12 that add up to 7 are 4 and 3. I'll cancel those 4, x plus 4s, and I'm left with 5 over x plus 3. So far, we so good. We feel okay about if I gave you one with common denominator, which I'm going to do on the test, don't worry. Let me give you one just so that you can get warmed up and feel good about it. You just add those numerators or subtract those numerators. So now let's turn our attention, example 3. In example 3, are these denominators the same? No. Okay, so now what to do here? So we have to get the common denominator. I'll be honest with you. I know that we don't like adding and subtracting numeric fractions, but I think finding common denominators with our rational expressions, our algebraic fractions, I think it's a little bit of an easier process. Because I'm just going to make a little note. Okay, I'm just put an asterisk right here. This is kind of how I can boil it down to finding a common denominator of our polynomials. The common denominator, the LCD, the least common denominator, is always one of each factor you take one of each factor, and then if there are powers, use the highest power. If you do have a coefficient, I showed you way back when we were solving equations and we were clearing fractions. If you remember, I just used the listing method. It's going to get you the common multiple pretty quickly most of the time. So then we'll come across a case where we have to do that. But let's start with purely algebraic fractions so that we can get used to doing this when I have like our binomials here down at the bottom. So looking at this, I've got 7 over x plus 4 and 11 over x minus 5. So the first thing we're going to do is we're going to figure out what's the least common denominator. So again, don't be afraid to make a mistake. Okay, mistakes are opportunities to learn. What are the factors that I need for my common denominator? Well, what is one of the denominators? Not just 4, because that 4 goes with something. What does that 4 there go with? X. There you go. So that's the first factor I need. I need x plus 4. Great. Okay, from here, we're going to practice, and we're going to get better at this. So don't worry. What's the other factor then I need? I need x plus 4, and then I need... Perfect. Great job. Yes. X minus 5. It's not just 4 and negative 5. I understand the desire to do that. Remember, just like with canceling, that 4 goes with this x. This 5 goes with this x. They are a pair. So this makes a whole factor, x plus 4. This makes a whole factor, x minus 5. There's my common denominator. So here's what I'm going to do. I'm showing you my process. If you have a different process that works for you, I 100% understand. That is great. So I'm going to take this common denominator and I'm going to write it once underneath each of these fractions. Because what I want to do is I want to get a setup that looks like these things right here that already had the common denominator, and then we just added. So here's what I'm going to do. I'm going to take the x plus 4 and the x minus 5. That's my first fraction, plus x plus 4. X minus 5, that'll be the denominator of my second fraction. I'm just giving you a second. I'm pausing so you have a second to catch up. So I don't want to get far ahead of you here. Okay, so now help me observe what's different. And when I'm looking at the first fraction, the 7 over x plus 4, and now I look at the common denominator, what's missing from this fraction up top that I need? Yep, an x minus 5. So I like to write out my work. I'm going to write an x minus 5 up here. That's what I need. I need to multiply the top and the bottom of that by x minus 5. That's what's missing. So in my numerator now, I have 7 times x minus 5. I'm just going to go ahead and distribute that because I'm going to have to collect like terms here in a minute anyway. So that's 7x. And then 7 times minus 5 is minus 35. There's my new numerator. I'm not going to reduce that fraction. My whole goal here is to, basically, I'm unreducing the fractions so I can add them together. All right, so here's what I'd like you to do. I want you to identify what's missing from this fraction and then multiply top and bottom of this fraction and tell me what the new numerator is going to be. So I'm going to give you 30 seconds to create what you think the new numerator is going to be of the second fraction. All right, the thing that is missing here is the x plus 4. So I'm just going to go ahead and fill it in. And now I'm going to now distribute. So I've got 11 times x is 11x. And then 11 times 4 is plus 44. Anybody get something different that we need to talk about there? So what I've done, just to recap, is I identified what the common denominator was by picking out one of every factor that I saw. Then I wrote that common denominator so that I could adjust my numerators of the two fractions. Now that they're all adjusted, I'm almost done with the problem. 7x plus 11x is 18x. Negative 35 plus 44 is plus 9. The denominator is x plus 4, x minus 5. At that point, if you saw that you could factor a 9 out of the top, that's 100% fantastic. But unfortunately, in this particular problem, nothing's going to cancel. So if you left your answer as 18x plus 9 over x plus 4, x minus 4, or x plus 4, x minus 5, that's great. You could stop there. I'm just showing you why we don't need to reduce. When I factor out the 9, 18x, factor out the 9, that's 2x. 9, factor out the 9, that's plus 1. And you can see I don't have any factors in common. So I didn't even need to do that step. I was just showing you why we can't reduce it. All right, that's the first problem. Flip the page. Your first problem is almost identical. I just changed the numbers slightly. So exercise 6 at the top. Please go ahead. Well, let's do this in phases. I'm going to give you 20 seconds. I want you to write off on the side here, what is the LCD of these two things? So I'm going to just write up here, what's the LCD going to be for this problem? All right, somebody tell me what's one of the factors I need in my LCD? Okay, y plus 2. And what's the other factor? Excellent. Great job, everybody. Appreciate that. All right, now finish out this problem. Do what I did before. You're going to write that down for each fraction. Then you're going to adjust the numerators and then add them up. Okay, so on this particular problem, here's my common denominator. That's what you already told me. So what am I going to multiply the first fraction by to make it look like the common denominator? Yep, perfect. Y minus 3. And when I do that, the numerator becomes 3y minus 9. We good so far? All right. What do I have to multiply the second fraction by to make it look like the common denominator? Yep, perfect. Excellent. And so then the numerator becomes 4y plus 8. Once you've done that, you've done the hardest part to the problem. Okay, and that's difficult. I would never tell you it's not. Once you do that, though, it's all downhill from here. Now I'm going to add up the numerators. 3y plus 4y is 7y. Negative 9 plus 8 is negative 1. That doesn't factor at all, so I don't have anything else I've got to do except write my denominator right here, and we're done with the problem. All right, if you got a question, ask it. I'm going to turn our attention to exercise 7, but I've always got time for questions if you've got one. So exercise 7, I'm going to give you 20 seconds. Identify what you think the LCD is. What's the least common denominator we're going to use here? What's one of the factors I need? Yep, x plus 3, great. And what's the other factor I need? Plain old x. It doesn't matter. I like to put the plain old x first, but if you put it afterward, it doesn't matter at all. Okay, there you go. You need an x and an x plus 3. Okay, you need both of them. I know that the x plus 3 has an x in it, and sometimes students will try to say, but there's the x. But remember, this x goes with the plus 3. It is a completely different value. Okay. All right, go ahead and finish out that problem. Use that common denominator. So my common denominator, this is what you told me, is x times x plus 3, x times x plus 3. So the first fraction, what do I have to multiply top and bottom of this first fraction by? The x, yep, just the other one. Fantastic. So that is going to be in the numerator 5x, and that's it. There's nothing else there. And then how about the second fraction? What do I have to multiply top and bottom of the second fraction by? Yep, x plus 3, good. Sounds like you're getting the routine of it. And once you get the routine of it, it never changes. So the numerator is 2 times x or 2x, and 2 times 3 plus 6. Okay, that's the hard part to the problem. The rest of this, I'm just going to collect those like terms. 5x plus 2x is 7x. And then there's no number here, so plus 6. And then x times x plus 3. 7x plus 6 does not have a common factor, so there is nothing else to do on that problem. We are 100% completely done. All right, I have one more type of denominator to show you, and then you've seen basically everything I can show you. Then we're going to go through and do 3 similar problems that are just subtraction, okay, with similar denominators. And then when we flip the page, we're just going to continue, practicing. So looking at exercise 8. I'm going to have you find the common denominator in just a second, but notice these are just single terms. Nothing's being added or subtracted. So I'm going to ask you in a moment to tell me or propose what the common denominator is. And you have to do 2 things. You need to figure out what's the coefficient, okay, using the listing method, okay, if you need to figure out what the common multiple between 3 and 4 is. And then you need to tell me how many x's we're going to need. And if you don't know, read the note we made at the bottom of the first page. All right, so let's see what you proposed. And remember, if you didn't quite get this, that's okay. If you look down exercise 9, you're going to get your chance to make up for it then. So don't beat yourself up. Don't claim you're never going to learn it. You can learn this. Okay, what's the common multiple between 3 and 4? 12. Yep. Okay. 12. I showed you the listing method a long time ago. You don't have to write this down. I'm just going to slide the page up to the top. If you don't have a way to figure out a common denominator, here is the quickest way that I know how to show you. Okay, I'm going to take the number 3, I'm number 4, and all you do is you list out the multiples until you find one that matches. And so what I mean by that is, okay, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and you just keep going on and on. You can always add more to the list. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Oh, there it is. Okay, 12. That's the lowest multiple they have in common. So 12. And then how many x's do I need? You always take the highest power. Yep, so I need 12x to the 3rd. All right, well, let me walk you through the rest of this. Like I said, exercise 9, you're going to get your chance to redo this whole thing just with different numbers. So we're going to take that 12x to the 3rd. We're going to write it underneath each fraction. And now, what do I have to multiply by to change the 3x squared into 12x to the 3rd? Yep, a 4 and an x. The 4 times 3 will make 12. The x times the x squared will make x cubed. Yep, so I got to multiply 4x. And when I do that, the top becomes 4x times 2, or 8x. All right, the second fraction, 4x cubed. What do I multiply that by to make it 12x cubed? Okay, I'm going to agree on the 3, but I don't need any more x's. This denominator already has an x cubed. And this one's an x cubed, so we're good on the x's. But I definitely need the 3. And so in the top, 7 times 3 is going to give me 21. Again, that's the hard work of the problem. That's definitely difficult, takes practice. And so then from there, my numerator is just going to be 8x plus 21. 8x plus 21 doesn't combine. And then my denominator is 12x to the 3rd. All right, so we're going to do similar problems to what we've just done with these first 3 at the top. And we're going to go back and we're going to do them with subtraction. Okay, just to practice that. And it's going to help us practicing common denominators. It's going to help us doing the whole thing. I'm going to help you with the first one. The first one, example 4, this is my example. So here we go. I've got 5 over x plus 4 minus 2 over x minus 6. So here's what I'm going to do. I'm going to give you 20 seconds. I want you to identify what is the common denominator we're going to use for this problem. Let's see. All right, what you propose to me for the common denominator? Love it. Thank you very much. X plus 4, x minus 6. Well said. Okay, so let's go through this. And so now I'm going to take that x plus 4, x minus 6. It's the denominator of each fraction. This time, just be careful. Instead of a plus like the previous problems, we have a minus sign here that we'll have to deal with in a little while. So now, do me this favor, because you know how to do this, or you've seen it a few times. I want you to adjust the numerators for each of the fractions. I'm going to give you 35 seconds to adjust those numerators. Okay, so what I'm hoping you did is the first fraction, you multiply by the x minus 6. And when you do that, the numerator became 5x minus 30. And then the second fraction, you multiplied by the x plus 4. And when you did that, that numerator becomes 2x plus 8. Hopefully we're all good. And then from there, the only difference in this problem, the reason I'm walking you through it is just it's a subtraction. And again, we've got to remember, if you don't need to distribute the minus sign, that's fine, but you've just got to figure out a way that you remember you have to subtract 5x minus 2x and then negative 30 minus 8. Okay, so somehow you have to remember that. The way I do it, because I will forget, okay, I will forget to do the second one, is I'm going to distribute this minus sign. So I'm going to make this a minus 2x and a minus 8, and I'm just going to add them up. So 5x and minus 2x is 3x. Negative 30 and negative 8 is negative 38 over x plus 4, x minus 6. And I'm done. All right, exercise 9, that's one for you. I'm just going to keep doing the thing where we pause and we figure out the common denominator just so that we're all on the same page. So 20 seconds, figure out what the common denominator is for exercise 9, please. Exercise 9 is similar in structure to the one that's right above it. All right, what did you think the common denominator is going to be? Yep, 30 x to the 4th. The common multiple between 5 and 6 is 30. You can do that by listing like we did previously. And then you always take the highest power. So x squared, x to the fourth, you take x to the fourth. All right, go ahead and finish that problem now. Go ahead and subtract those two and combine them into one fraction. All right, so 30x to the fourth is the common denominator. So I need to turn 5x squared into 30x to the fourth. So I'm going to multiply the 5 by 6. And then the x squared, I multiply by another x squared. That's going to give me 30x to the fourth. So I'll do the same thing in the top. 6x squared times 9. And 6 times 9 is 54x squared. The second fraction, I've got to turn 6x to the fourth into 30x to the fourth. Well, notice I've already got all the x's I need. I've got 4 of them, so I just need to take that 6 and multiply by 5. And so 7 times 5 is 35. I've now adjusted both fractions successfully. Now it's just a matter of subtracting. And this is a nice problem because I don't even have to combine anything. It's 54x to the second minus 35. Those are not like terms. I can't combine them at all. And then in the denominator, it's 30x to the fourth. You don't ever change your common denominator. And done. Nothing else to do on that problem. So at this point, I think we've got the basic gist. I know we need to practice more because we've just done a few, but there's really nothing else to tell you about. So we're just going to go through examples where I'm gonna change one little thing here or there just so that you see any possible thing that can happen in this. So exercise 10. I want you to do exercise 10. The only difference in exercise 10 than the other ones is there's x's in the term in the top, but that doesn't affect anything at all. Everything works exactly the same. Common denominator, change your numerators, collect like terms. That's it. Go for it. Just to give us all a nudge. What did you start out with as your common denominator? Well said. X plus 4, x minus 7. Okay, keep going. Just wanted to make sure we're all on the same page. Right, so the first fraction, we're going to multiply by x minus 7. That's what's missing. And so here's the only thing that's different on this problem than the previous ones. Now I'm not just multiplying 2, I'm multiplying 2x. So 2x times x is 2x squared, and 2x times negative 7 is negative 14x. Okay. Nothing about my process has changed, though. The second one, I'm going to multiply by x plus 4. And when I do that, 3x times x is 3x squared, and then 3x times 4 is 12x. Once again, I've got myself a subtraction problem here. And so again, to remind myself to subtract everything, I'm going to change my signs to a negative 3x squared and a negative 12x. And now I'm going to collect my like terms. I got 2x squared and negative 3x squared. That's negative 1x squared. I've got negative 14x and negative 12x. That's negative 26x. And then over x plus 4, x minus 7. Done. Nothing else to do on that problem. All right, let's roll to the next page. The reason I put exercise 11 there is we've done problems that have had one variable like this. This one just has 2, just to show you that the process is the same. So again, you're going to choose your common denominator. You're going to find the common multiple between those coefficients. And then you're going to figure out how many x's do I need, how many y's do I need. So go ahead and figure out that common denominator. All right, so what's the common multiple between 12 and 8? 24, great job. You can get that by listing. How many x's do I need? X to the 5th, and then how many y's? Okay, y to the 3rd. Okay, go ahead and finish up that problem if you hadn't been doing that already. And so I've got to first turn 12 x to the 5th y squared into 24 x to the 5th y cubed. So what do I have to multiply that by? Any thoughts on that? Perfect. 2y. We already got enough x's. 12 times 2 is 24. Y squared times y is y cubed. That's a great job. And so when I multiply the top by 2y, that turns out to be 10y. And then I've got to turn 8x to the fourth, y to the third into 24x to the fifth, y to the third. And so what do I multiply that one by? Okay, we're going to do 3, not 9, I think I heard, but 3, because 8 times 3 is... Oh, okay, no worries, no worries. And then x times x to the fourth is x to the fifth, and then I don't need any more y's. Okay, so there we go. And so then 3 times 3x is 9x. Again, that's the difficult part to the problem. But once we got that, it's all downhill from here. We're subtracting. These things are not like terms. So I've got 10y minus 9x over the 24, x to the fifth, y to the third, and we are done with that problem. All right, so the next problem, the reason it is here and present with us is because we haven't done one where we've had to factor the denominator. So here's what I'd like you to do. I'm going to give you a minute or two to do this. I want you just right below the problem here. I'm going to write my parentheses. I want you to factor these two denominators. Okay? Each of those two things will factor. They're trinomials. You're going to unfoil them. And then once you've factored them, I want you to propose to me what you think the LCD is. Remember, the LCD is one of every factor you see, and then the highest power if there's powers. All right, so the first trinomial, x squared is x and x. The signs, since this is a -3, the signs are plus and minus. And then the two factors of 3 that are 2 apart, well, again, the only two factors of 3 are 1 and 3. So I'm going to make the 1 positive, 3 negative, because it's got to add up to a -2. And then the x squared minus 5x plus 6. Again, x squared is x and x. My signs are going to be the same. The 5 tells me they're both going to be negative. And then the two factors of 6 that are going to add up to 5 are 3 and 2. Okay. So the first challenge for us is getting those denominators factored, and we're going to have to do that 1 or 2 other times on this back page. And now the least common denominator. What are the factors I need for the least common denominator? X minus 3, x plus 1. Is there another factor? The x minus 2. Yep. One of everything you see. I don't need the x minus 3 twice because it's not raised to a power. Each of them has an x minus 3, but that's okay. So your least common denominator is one of everything you see. And then if there's ever powers, you take the highest power. And one of everything I see is I see an x minus 3, I see an x plus 1, and I see an x minus 2. Okay, now what you're going to do is just what we did before. You're going to take those 3 factors, that's your common denominator. You're going to write it once for each fraction. And then you're going to figure out what you're going to multiply by, what's missing from each fraction, and then add up the like terms. You're almost done with the problem. thing that's missing from the first fraction is the x minus 2. So we'll multiply there by the x minus 2. And so in the numerator, that makes 4x minus 8. And then the thing that's missing from the second fraction is the x plus 1. So I'm going to multiply by x plus 1 right here. And so that's going to make 3x plus 3 in the numerator. So it's the same process. I understand it feels a little different because we've got 3 factors now for the common denominator instead of 2. Okay, that's why I wanted to run through it. And finishing up, though, I've got 4x plus 3x, that's 7x. Negative 8 plus 3 is negative 5. And then over my x minus 3, x plus 1, x minus 2. All right, we're rolling to the finish line. You're almost done. Exercise 13. The reason exercise 13 is up there is just to show you that if there are 3 fractions instead of 2 fractions, your process is the same. So looking at this, there is one of those fractions that you have to factor the denominator. Is it the first, the second, or the third fraction that you have to factor the denominator? The third one. So go ahead real quick, factor the third denominator, and then tell me what write down what your least common denominator is. So you're factoring that third denominator, and then you're taking one of every factor, and then if there happens to be a power, which there's not on this one, you take the highest power. So when I factor that third denominator, I can factor an x out of it. And when I factor an x out of the x squared, it leaves me x. When I factor the x out of the negative 3x, it leaves me the minus 3. So there's my 3 denominators. I've got the denominator x minus 3, I got the denominator x, and I got the denominator x times x minus 3. So what is one of every factor you see? Perfect. X and x minus 3. One of everything. And so now what you're going to do, I'm going to do this next step. What you're going to do is you're going to take that common denominator, x and x minus 3. I'm going to write it once for every fraction. And from here, you're just going to adjust the numerators like we have been all along, and then collect your like terms. My first fraction has an x minus 3. I've got to change it into this. So I've got to multiply that first fraction by an x. So the numerator becomes 5 times x, or 5x. Okay, and we're off to the races. The second fraction just has an x in the denominator, and it needs to be this. So I got to multiply the second one. I got to squeeze this in. Got to multiply this second one by x minus 3. And so when I do that, the numerator becomes 2x minus 6. The good news about the third one is the third fraction already has both the x and the x minus 3, so I don't have to do anything to the third one. So its numerator is going to stay 6. There's nothing to do to that one. Again, that's the hard parts of the problem. That is difficult, okay? That's the part that's going to take you the most practice. But once you do that, now it's just collecting like terms. So I've got 5x plus 2x, that's 7x. Then I have negative 6 minus 6 more, that's minus 12 over x minus 3. All right, next problem. I tried to do us a little favor. We're almost done. Try to do us a little favor on this problem. Exercise 14, you notice the denominators of the two fractions are the same denominators as exercise 12. So just to save us a little time, I made this one so that the LCD is the same as 12. Okay, the one right above it. So all you're going to do here is you're going to write down that common denominator. You're going to make the adjustment to the numerator. The purpose of this problem being here is on the homework, there's a few where you have to FOIL the numerators. Okay, so it's a little extra busy work. Apologize for that. So go ahead and do that little bit of extra busy work and then combine your like terms. Okay, so just comparing with exercise 12, the denominator x squared minus 2x minus 3, we had to multiply that by x minus 2 in the other example. And so now I have to FOIL. Okay, so first outers, inners, last. So I'm just going to go ahead, first outers, inners, last. That's going to give me x squared as my firsts. My outers are plus 4x. My inners are minus 2x. And my lasts are minus 8. Then the second one, comparing with exercise 12, when we had the x squared minus 5x plus 6, we had to multiply that one by x plus 1. And so when I go ahead and do that, I'm FOILing again. My first 2x times x is 2x squared. My outers, 2x times 1 is 2x. The inners, negative 3 times x is negative 3x. And then my lasts, negative 3 times 1 is negative 3. As with the other subtractions, okay, this is the last subtraction for the day. As with the other subtractions, I need a way to remind myself I got to subtract all of those terms. So I'm just going to go ahead. This is my process. I'm going to change all these signs by distributing that negative. That helps remind me. And now here's what's left over. I've got x squared And then negative 2x squared, that's negative x squared, negative 1x squared. 4x minus 2x, that's 2x. Minus 2x, that's 0 x's. Plus 3x, that's plus 3x. And then I have a negative 8 and a plus 3 is a negative 5. All over x minus 3, x plus 1, x minus 2. Okay, that's a little bit of busy work. I know none of us enjoy all that busy work, so I don't think there's that many problems like that in the homework. So, all right, one more. This one's pretty straightforward. So exercise 15, last one. So first thing to do, factor those two denominators like we've done previously, and then identify the common denominator. And you're welcome to keep working from there if you like, or if you want to stop and wait for me, that's fine too. All right, so factoring here, the first one, x squared is x and x. The two factors of 25 that are going to add up to 10 are 5 and 5. So notice I have the same factor times itself, so that's x plus 5 squared, because there's two of them. The second one, x squared, is x and x. The two factors of 10 that add up to 7 are 5 and 2. So there we go. Those are different factors. So remember, the least common denominator, this is the reason for this problem. The least common denominator is one of every factor you see. And then when you have a power, you take the highest power. So what's my least common denominator going to be? Okay, I will agree that this is one of every factor I see, x plus 5, x plus 2. There's one minor adjustment I have to make, though. What's the highest power on the x plus 5? Yeah, there's two of them. So I need the x plus 5 squared and then x plus 2. One of every factor you see, so that includes the x plus 5 and the x plus 2. But when you have multiples, you always take the highest power. You always take the most. So just for time's sake, because we're almost out of it, apologize for not doing better with my timing. So here we go. Let's finish this problem. I've got x plus 5 squared and x plus 2. And then plus x plus 5 squared, x plus 2. The first denominator already has the x plus 5 squared. It's already got both the x plus 5s. It's missing the x plus 2. So I'm going to multiply here by x plus 2. And so what that makes my first numerator is 5x plus 10. The second denominator has one of the x plus 5s and the x plus 2, but my common denominator needs to have two x plus 5s, so I have to multiply that one by x plus 5. And so now 2 times x is 2x, 2 times 5 is 10, and we're just about done at long last. 5x plus 2x is 7x, 10 and 10 is 20, all over my common denominator. And there you have it.